Here's a homework help video for lesson 4.3. I'm working on the homework from page 247. I've chosen 3 problems that work a little differently than the ones that I looked at in class. So just wanted to maybe help you out with these, and hopefully that'll help you with others like these. So here's number 26. Went ahead and set it up for us, and so let's just get right into it. I'm dividing first term, which is 3a, into first term, which is 6a squared, and that goes 2a times. And again, I multiply 2a times 3a is 6a squared. 2a times negative 2 is negative 4a. Set up the subtraction. The a squares cancel. Negative 3 plus 4 is 1, positive 1a, and I'll bring down the 9. Okay, well here is a kind of an unusual situation. We're having to divide 3a into 1a. So off to the side, let's just take a look at what that would look like. It's really saying a divided by 3a. And if you cancel the a's, you end up with the fraction 1/3. Remember, there's an invisible 1 coefficient here in front of a. So canceling this division of 3a divided into a, canceling the a's, we end up with 1/3. Now multiplying by 1/3, 1/3 times 3a is just a, and 1/3 times negative 2 is negative 2/3. All right, set up the subtraction, and of course the a's will cancel. If you want to think of 9 as 27/3, then you're adding 2/3. That gives you 29/3. Okay, well, the way we looked at in class, we write the answer is we take the remainder, which in this case is 29/3, and we put that over the divisor, which is 3a minus 2. But we've talked earlier that we can't leave complex fractions, and that's what this is. We cannot leave an answer like this, so we need to simplify. And just think back to what you learned previously in earlier math classes. In this case, dividing by 3a minus 2 is the same thing as multiplying by 1 over 3a minus 2. Okay, so the way we'll simplify this complex fraction is instead of dividing by 3a minus 2, we'll multiply by its reciprocal. And now it's just multiply straight across. 29 times 1 is 29. Over 3 times 3a minus 2, that's 9a minus 6. And that becomes the remainder part of our answer. Okay. So I'm going to erase this complex fraction, and I'm going to write in the correct way of taking care of the complex fraction. So my final answer here will be plus 29 over 9a minus 6. All right, little different than the problems we looked at today. The process is the same, but I just wanted to help you out a little bit because that does end up a little differently. We simplify a little differently than what we did previously in class. Okay, let's take a look at this one. This is number 27. Set it up for us, so let's just jump right in. I'm going to divide first term, 3x, into first term, 6x to the 5th, and that should be 2x to the 4th. Okay, now multiply. 2x to the 4th times 3x is 6x to the 5th. 2x to the 4th times 1, of course, is 2x to the 4th. I'm going to subtract. And now I'm going to do 5 minus 2, which is 3, x to the 4th. And I'm going to bring down the next term. Okay, now I'm going to divide 3x into 3x to the 4th, and that goes x to the third. Okay, again, if you need to come off to the side and just work these out individually, that would certainly be okay. The 3's cancel, and as you can see, if you subtract the exponents, you get x to the third. Okay, and now multiply. So x to the third times 3x, 3x to the fourth, x to the third times 1. Okay, and we're going to subtract, and that all becomes 0. So now we're doing, I'll just go ahead and bring down this plus x. So now I'm dividing 3x into, obviously we're not dividing into 0, we're dividing 3x into negative 3x squared. So negative 3x squared divided by 3x. This may not be necessary for everybody, but I just want to make sure you understand. That's going to be negative x. Okay, hopefully everybody can see that. Negative x. I know we've got a space here, but in our final answer we'll show it all together. All right, so negative x times 3x is negative 3x squared, and negative x times 1 is negative x. Subtract, the x squares cancel. 1 plus 1x is 2x. Okay, and then of course we don't really need this. I'm kind of preparing you for tomorrow for our new topic. That's why I'm filling in all of the missing terms and in this case a missing constant. But if you wanted to bring down the plus 0, that would be okay. But at this point I'm trying to divide 3x into 2x. 3x, in other words 2x being divided by 3x. Well, we have a similar situation as what we had earlier. The result of that is just going to be 2/3. Okay, so 2/3 times 3x, that's going to be 2x. If you were wondering how I got that, let me just, I'll just show you. 2/3 times 3x over 1, if you want to match up numerators and denominators. Remember, these 3's would cancel, and you just have 2x over 1, which is 2x. Okay, so we did 2x, or 2/3 times 3x. Now let's do 2/3 times 1. And subtract. And we end up with negative 2/3. Okay, so it's going to look like this. Negative 2/3 divided by 3x plus 1. Well, once again, complex fraction, we cannot leave our remainder in this form. So dividing by 3x plus 1 is, come down here, dividing by 3x plus 1 is the same thing as multiplying by 1 over 3x plus 1. Okay, so when I multiply these together, just straight across, negative 2 times 1 is negative 2. 3 times 3x is 9x. 3 times 1 is 3. So the simplified form of this complex fraction is going to be negative 2 over 9x plus 3. Let me erase all this. So it's okay if you want to say plus negative, or if you just want to say minus, which I think that's what I'm going to do. Either, it wouldn't be wrong in either case. Hopefully you can see that it is going to be negative. So if you just want to do plus negative, that's all right. I'm just going to show it as minus 2 over 9x plus 3. And so this ends up being final answer. 2x to the fourth plus x cubed minus x plus 2/3 minus 2 over 9x plus 3. Okay, let's try one more. Number 29. Okay, got it set up for us. And so let's start the division. First term, 2b squared, into first term, 2b cubed. Well, that goes b times, 3b times, sorry. That's right, b times. 2b squared into 2b cubed, that's b. Now let's multiply. b times 2b squared is 2b cubed. b times b is b squared. b times 1 is b. Subtract. The b cubes cancel. Negative 6 minus 1b squared is negative 7b squared. 8 minus 1b is 7b. Okay, and now we're going to divide 2b squared into negative 7b squared, and we got a similar situation as before, so let's just go over here and take a look at it. So negative 7b squared divided by 2b squared is negative 7 over 2, or minus 7 halves. So when you multiply negative 7 over 2 times 2b squared, if you want to think of it over 1, these would cancel, and you're left with negative 7b squared. Okay, and now we need to do negative 7 over 2 times b, and negative 7 over 2 times 1. Of course, we could bring down this plus 0 if we want to line up those. Okay, and now let's subtract, and the b squares cancel. So we might want to think of this as 14 over 2 instead of 7 to make these same denominator. So 14 over 2 plus 7 over 2 is 21 over 2b. And then 0 plus 7 halves, of course, is plus 7 halves. So that ends up being our remainder. And so once again, we've got this situation where we have this remainder. B squared is too big to divide into b. So we're going to have this remainder, and I'm going to write it as 21b plus 7 over 2. Okay, since these have the same denominator, I'm just going to add the numerators together over the common denominator, and all of that is going to go over my divisor, 2b squared plus b plus 1. Okay, another complex fraction. So dividing by 2b squared plus b plus 1 is the same thing as multiplying by its reciprocal, or its inverse. So do not leave complex number answers. Okay, change them by using the property dividing by a number is multiplying by its inverse. And now that's going to get us to our final remainder answer. I think I'll just put it up here. 21b plus 7 times 1 over 2 times 2b squared plus b plus 1. That's 4b squared plus 2b plus 2. All right, and that's our final answer for number 29. So I hope that helps, and if you have any other questions, you're free to email me, and work hard on it, and we'll see how you did next time.